Welcome, everyone. My name is Chaba Mutsielwa. I'm from the Speakers Firm. Welcome and thank you for choosing to join the Empower Entrepreneurs Digital Conversations, a COVID-19 discussion hosted by EmpowaWorks. A very special welcome to Professor Tshilidzi, Marwala, who will deliver the keynote in a few minutes. We have a broad representation of stakeholders joining us directly via Zoom, and they will post their questions directly onto the chat box. At the end of the keynote, there will be a Q&A, and we'll try to answer as many of the questions as possible. To get a direct invite to the next talk that will be happening on Monday, on the 11th, 2020, by Professor Bonang Mohale, please contact our WhatsApp number 082-088-5262 or visit the EmpowaWorks website, where you can also get information about empowerment, empower women, empower youth, speakers firm, leadership summits, and other events. We are live on the following EmpowerWorks digital platforms: YouTube, Twitter, Facebook, and the hashtag that we've been following for these conversations is hashtag EmpowaEntrepreneurs. Yeah, during this lockdown period, the 4IR and the 5G discussions have just exploded. And that's why we have Professor Tshilidzi Marwala today. Over to you, Prof.
Thank you very much, Sishaba and Simpiwe, for inviting me to come and speak to you this evening. Also, Rian, thank you very much for making sure that the technology is operating the way it is supposed to operate. I've titled my talk on the fourth industrial revolution: artificial intelligence, 5G, and superstition. This is really what I'm going to talk about. Now, originally I had prepared a presentation that I was going to show, because I actually believe that visual demonstration is actually much better. But I am not going to do without the presentation. I'm just going to continue to speak until the end. Now, we live in a very interesting times. COVID-19 is causing havoc to the world economy. The world economy is almost experiencing a depression similar to the depression of the 1930s, which ultimately led us to the Second World War. So this is actually quite serious. Towards the end of this talk, I shall be talking about the post-COVID world. How will it look like, and how should we position ourselves as South Africans so that we are not left at the periphery and the dustbins of history? Now, what is this thing called the fourth industrial revolution? The fourth industrial revolution is a process of modernization of means of production, or the production forces that started in the first industrial revolution in the 1700s, where the steam engine automated the industry. For example, the textile industry of the time in the 17th century was automated using machines. For the first time, human beings were able to build machines that could be used for production. Of course, the country that was at the center of that is the United Kingdom, and ultimately, because they had a first start on the first industrial revolution, they used that in order to go out into the world and conquer the rest of the world. In fact, that small island with so few people managed to conquer a big country such as India, which was more than 10 times its size. And they were able to do that because of technology. Then the second industrial revolution came about It gave us electricity and the electric motor, mass production of goods and services, the assembly line where goods and services can be produced at a massive scale. At the center of an assembly line was an advice that was given much earlier by Adam Smith, the idea of specialization, that if you could have a person specializing on doing one task in manufacturing, it is better than if one person specializes in all the tasks that are required to make a car, for example. So the first industrial revolution gave us mass production of goods and services. And it largely happened in the United States as opposed to the first industrial revolution that happened in England. Then came the electronic age, the discovery of a transistor, effective and efficient switch that that object called a transistor is. As a result of that, we entered the digital age. It is called the digital age because it was the age where two numbers became very important, ones and zeros. Of course, the idea that you could be able to represent everything that could ever be written using just ones and zeros had been known for some time. What had not been known was how to do that efficiently. And of course, the transistor was able to do that. And because of a transistor, we entered the electronic age. Computers came into the being. Our phones came into the being. Very important. Now we are living in what is called the fourth industrial revolution. This is a confluence of technologies in the cyberspace, in the physical space, and in the biological spaces. They are fused into one. For the first time, men and machines are becoming one system. We know about Elon Musk, who is talking about implants into our brains. You implant devices that ultimately are going to help us think better, make decisions better. So that is the confluence of the cyber, the physical, and the digital. The reason why I use, and the biological, the reason why I use cyber is because computers that have been using ones and zeros to do what they do best for the past 70 years are now moving into the quantum domain. And of course, quantum is a piece of knowledge that came about at the beginning of the last century. The father of quantum mechanics is Max Planck, who was able to introduce this. In fact, Einstein himself won a Nobel Prize in quantum mechanics. So quantum computers are going to be much faster than digital computers. And once quantum computing comes into being, then all the cyber security infrastructure that we have created is going to fall to the wayside. So it will be much easier to break into a digital computer using a quantum computer. There are other aspects of the fourth industrial revolution that are very important. The other one is artificial intelligence. It is important because it is revolutionizing all aspects of our lives. I personally did a PhD at the University of Cambridge in artificial intelligence. And then you have other technologies of the fourth industrial revolution, 5G. You are going to hear much more about 5G and artificial intelligence in this talk as the time goes on. Now, what is this thing called artificial intelligence? A technique of making machines intelligent. And how do we do that? We use data and a computer and mathematics combined together to create an intelligent machine. Such machines can be as intelligent as human beings, and in certain tasks, such machines can be much more intelligent than human beings. I'll give you an example. Around about 1997, IBM created a piece of artificial intelligence machine called Deep Blue. Deep Blue was trained to play chess. At that point, the chess champion was Garry Kasparov. Garry Kasparov was defeated by a machine. So in this regard, the best chess player is no longer a human being. It is an artificial intelligent machine. Now, in medical domain, we are hearing now that machines are able to read medical images such as X-rays better than human doctors. This is actually quite crucial because what it actually means, it means a task that used to be done by a medical specialist called a radiologist perhaps can be done much, much better by a human being, by a machine than a human being. And it will have all sorts of implications on the world of work, and we will talk about this towards the end of the time. So artificial intelligence is changing all aspects of our lives. It's so much changing all aspects of our lives that countries are developing strategies on artificial intelligence so that they cannot be left behind, so that their economies cannot fall by the wayside. For example, the artificial intelligence strategy that was launched last year by India is positioning India as a hub of artificial intelligence. China has an artificial intelligence strategy. The United States, the White House, developed a blueprint of artificial intelligence in the United States. This is what we see. And I have to emphasize this, that when countries publicize their strategies, we should not make assumption that these are their strategies. They publicize their strategies maybe to signal that they also are looking into this technology. They would not reveal their strategies because if they reveal their strategies in their entirety, then somebody else can copy it. So whatever we read about coming from China or from India, from the United States, we should know that it is not even half of what is happening. So indeed, artificial intelligence is changing the world. Here in South Africa, President Cyril Ramaphosa basically expanded the strategy, not just to concentrate on artificial intelligence, but broadly on the fourth industrial revolution. Because if you remember, fourth industrial revolution includes artificial intelligence, but it also includes other technologies. Blockchain that is now being used to create digital money. China has just introduced its own digital money, is also part of the fourth industrial revolution. Very, very important. So in this world where we are living in, we need to invest in technology. Our people must understand what artificial intelligence is all about. We should have experts at the highest level in this field of artificial intelligence and other fields that are relevant for the future. Now, the other technology of the fourth industrial revolution is 5G. 5G is a telecommunication technology. So what is telecommunication technology? This is a technology that we use in order to be able to communicate with one another. A telephone has been around ever since Alexander Bell discovered it more than 100 years ago. It has been around for a long time. But the original telephone line, for you to be able to speak to another person, there must be a cable that connects you to that person you are talking to. So 50 years ago, if you were talking to somebody in the United States, there will be a cable that will extend all the way from Johannesburg to New York, and you will go under the sea. So communication was only possible if there was a cable that connected the people who are communicating. This is what I would call 0G. Now, the first 1G was when we started communicating with one another without any cable linking us together. The easiest 1G technology that I can raise is what used to be called a walkie-talkie. A walkie-talkie, you would talk to somebody, but that somebody would not be connected to you through a cable. So you will talk to that person through the air using what is called electromagnetic waves. Electromagnetic waves emanated during the second industrial revolution, during the time when we discovered electricity and an electric motor, because electricity and an electric motor use the principles of electromagnetic physics. And people such as Maxwell were quite instrumental in creating that physics, and ultimately it led to Einstein coming up with the Einstein theory of relativity, because he was reconciling the physics of the first industrial revolution called Newtonian physics to the physics of the second industrial revolution, which is a Maxwellian physics. So now, in the first 1G, we're able to talk to one another. So only voice was the only instrument that we could use to talk to one another. Then we moved to 2G. 2G is basically when we started doing communication using voice plus a text. So you could type an SMS and somebody else can receive an SMS. If you did not want to type an SMS, you could pick up the phone and call that person and talk to that person on the other side. Very, very important. Then we move to 3G. 3G, on top of having voice and text, internet came into the being. So for the first time, we were able to surf the internet using our phones. Of course, it was not very fast. You know, if for those of you who still remember, every now and then it will go back to GPRS, which meant it was slower. Then it will come back to 3G. Very, very different times. Then we came to 4G, LTE, which is the one that is being used now. There, we could be able to download videos now, even in our phones. You could even download a movie. Movies will take about 6 hours to download in 4G. Now we're moving into 5G. So 5G is much, much faster than 4G. For example, a movie that will take 3 hours to download using 4G will take only 6 seconds. Imagine. Very, very, very quick. Why is it quick? It is quick because it is using relatively high frequencies. Now, what Einstein taught us in his theory of relativity was that the speed of light is the highest speed that any object on our universe can ever be able to reach. Frequency times wavelength, size of a wave, and you can think of a wave the same way as the wave that you see in a beach in Cape Town or in Durban, eThekwini, is the same concept. So a wavelength is the size of the wave. A frequency is the number of waves that pass a particular point in 1 second. If you multiply in electromagnetic waves, if you multiply the frequency by the wavelength, you get the speed of light. Now, if your frequency is large, then your wavelength is small. Because your wavelength is small, it means they can't travel too far. Because they can't travel too far, 5G requires that the transmitters that normally would serve the entire village will have to be put in our electricity poles closer to our homes, because you will have many of these transmitters. They are all over the place within our environment. And the reason for that is because these are short waves operating at higher frequency, but they are short waves and you require a lot of them. And once you do that, then it means that your internet is going to be very fast. So now, going forward, what does all this mean? The fact that these transmitters are going to be closer to our homes than the transmitters of 4G. And people have been creating all sorts of conspiracies. Some people are saying that 5G is dangerous. And some people are saying that it kills. Some people are saying that it is related to COVID-19. And all these things, I'm going to untangle them as we go on. Now, with this 5G, how do we make it happen? So you have something called a spectrum. Now, a spectrum is basically, a number of frequencies, the frequencies that I told you, which are the number of waves that pass a particular point. Now, if you have a radio station and you want to broadcast in that radio station, they give you a frequency, 104.8 hertz or megahertz. That is what they will give you. So you are given one frequency, and using that one frequency, you broadcast to all the people who are interested to listen to your radio station. So if now I want to receive information broadcasting from Tshilidzi FM, then I will tune to the frequency of Tshilidzi FM so that I can listen to them. So everybody is allocated a frequency. And the organization that allocates a frequency is ICASA. Very important. The same process applies to cell phone companies such as MTN. They are also allocated by ICASA a frequency. But that frequency is not one frequency, like Tshilidzi FM or Para FM. It is a frequency band or a frequency spectrum. So they might be allocated a frequency, let's say from 3 gigahertz to 4 gigahertz, so that they can be able to use all these frequencies that are in that band for us to be able to communicate. So unfortunately in South Africa, we have not allocated a frequency spectrum in the last 15 years. And as a result of that, because the spectrum is becoming even a rarer commodity, our telecommunication using cellular phones or downloading data is slowly becoming slower and slower. Because you have all these technologies that are developing. We go and surf the internet, and this surfing of the internet, or whether we are going to Facebook and we are live streaming a video, is actually assuming that we also have a sort of bandwidth that other telecommunication companies elsewhere have the bandwidth. So we have this the Department of Communication last year saying that they are issuing guidelines, and they have issued those guidelines, policy guidelines for the allocation of new spectrum, so that our companies are going to be able to invest in 5G and we can have faster internet. Now, what about the people in rural areas? Are they going to get 5G also? I was reading last week that Vodacom is going to be launching 5G technology in Johannesburg, Durban, and Cape Town. And I was asking myself, why only those 3 places? Why not in Dutuni, where I come from, or in Dutwa in Eastern Cape? Are we entering an era where the people in rural areas will have slower and slower internet, and people in urban areas will have faster and faster internet connectivity? And how do we bridge that digital divide? Because it is a digital divide. So those are some of the issues that we need to bear in mind when we start allocating the new spectrum to our telecommunication companies. Now, does 5G cause COVID-19? Does it cause coronavirus? 5G electromagnetic waves. Coronavirus, a living organism. Is there a connection between electromagnetic waves and a virus? There is none whatsoever. So that question is settled. The second issue, these transmitters that are closer to our homes, because 5G requires that, are they generating radiation that is dangerous? Are they operating at such high frequencies that they are going to cause diseases on us? Of course, there are many other types of waves that are dangerous. One type of wave is X-ray. The same X-ray that we use in hospitals in order to see what is inside our bodies. It's dangerous because it's very, very high frequency. So it can't be used without regard to the fact that an extended exposure to X-ray is not safe. So the medical fraternity have developed protocols about how long it can be used, and it still remains within the safe limits. The gamma rays, for example, also used in medical imaging, in nuclear medicine. Again, these are the frequencies that we should be careful when we handle them. And the people who work in radiology departments in hospitals, they are careful when they handle these things. Now, coming to our situation, are those towers that are closer to our homes dangerous? In particular, does the radiation they emit cause harm to people? Whenever we talk about radiation, people get very scared, because the first time we encounter radiation is in nuclear technology. At the end of last century, when nuclear materials were being understood, radioactive materials were being understood, we later found out that one of the pioneers of this radiation technology, a Polish lady who spent almost all her adult life in France, called Marie Curie, was so fascinated about this radioactive material that she used to put them in her pocket. And now we know that exposure to radioactive material actually destroys the DNA of people and ultimately causes cancer. And she died of cancer. Of course, Marie Curie remains the only person in the world to ever win 2 Nobel Prizes in 2 different science fields. She won a Nobel Prize in chemistry, and she also won another Nobel Prize in physics. Her husband won a Nobel Prize in physics, and her daughter also won a Nobel Prize. So it is one of those families that had so many people winning a Nobel Prize. Now, the radiation of Marie Curie, that Marie Curie was handling, is called ionizing radiation. Ionizing radiation is dangerous. The radiation that is generated by 5G is non-ionizing. It is not dangerous to the same scale as the ionizing radiation. In fact, there is no research findings that suggest that it is dangerous. However, as a scientist, I should be a skeptic. We have to, if people are feeling that further investigations have to be done, we have to do them, despite what the evidence is actually telling us. So this is really what 5G is all about. Now, before I come to an end, I really wanted to talk about COVID-19. Of course, I've already talked about its non-connection to 5G, but I also wanted to talk about how will the world look like after COVID-19. COVID-19, we know, it first emanated in Wuhan in China, and ultimately it went out to the rest of the world. The world economies are practically closed. OR Tambo and all other airports in South Africa are closed. We have never seen anything like this in our lifetime, and hopefully we will never see anything like this in our lifetime. It is a virus, and this virus actually causes flu types of symptoms. There are more people who are going to be infected by this virus than the people we report. In fact, there are more people who have been infected with this virus than the numbers that are quoted. The reason for that is quite simple. The people who tend to go for testing are people who are showing symptoms. And the majority of the people who are infected by this virus are going to be asymptomatic, which means they are not going to show any symptoms. So, what are we to do? Firstly, we need to understand the evolution of this COVID-19. How is it going to spread? Here at the University of Johannesburg, we have a great deal of people who are actually working on understanding the spread of COVID-19. Me and my student, my PhD student, who is also an qualified actuary, Rendani Mbuba, have actually published 2 papers on how this COVID-19 is going to spread out. And one of these papers has already been submitted to the World Health Organization. We use something called the SIR model, a susceptible, infected, and recovered model, to understand how many people probably are going to be infected by this virus. And what is the implication of that? When are we going to reach the peak of this virus? So I guess what I'm trying to say is that it's a big issue. COVID-19 is a big issue, but we will need to find scientific solutions to get out of this situation. Now, there are two scenarios going forward. Either we are going to find a vaccine for COVID-19, or we are not going to find a vaccine for COVID-19. There are many viruses that have come before. The HIV virus, almost 40 years after it was discovered, we still have not found a vaccine. So it is actually quite possible that we might not find a cure, a vaccine for this virus. So depending on whether we find a vaccine or not, the post-COVID-19 will look different. If we find a cure or a vaccine, then life will probably come back to where it was. It will become more normal. We will still be able to travel and so on and so forth. If we do not find a cure, then the future of transportation is going to be very, very different. The organization of our offices is going to be very, very different. Open space offices where people are sitting half a meter from one another are going to be the thing of the past. Elevators that require us to press, and pressing can be dangerous if somebody who had that virus had just done so before then, will have to be reconfigured. We probably will have to have voice-activated lifts, where instead of pressing 2, if you are going to the second floor, you will just say, I'm going to the second floor, and the lift will be able to understand you, and it will take you there. Traveling will be completely different. The buses that have people basically sitting few millimeters away from one another are going to be the thing of the past. When we go to other countries, visas will require us to have implants into us so that our movement can be traced, and if we are found to have been infected by a virus, then they can be able to track where we have been, who we interacted with, and quarantine the people. This is the post-corona world. So there are many, many areas that are going to be changed. The international relations is going to change. If you go to many embassies, maybe they will have a military attaché. These are people who will be based in embassies, and they will deal with military cooperation between two countries. Now more than ever before, we require our embassies to have health attaché, because movement of people actually in many ways can mean movement of diseases. There will be the economic questions. The fact that we are in an era where a particular good, the computer that I'm using here, the chip was made in the United States, and the rest of the computer was made in many parts of the country, will obviously change. Countries are going to bring all their manufacturing, all the value chain into their own homes. And it will have all sorts of implications for us as South Africans. If you go to East London, you will realize that the Germans are making cars in East London. In post-COVID, will that be possible? And what do we do about it as South Africans so that we are not thrown into the wayside? So I can see that Sishaba is telling me that I have been speaking for too long, and it is time for me to stop so that we can handle the questions. Is that so, Sishaba? Thank you.
Indeed, Prof, you could read my mind. I'm worried now that you now read my mind. There are questions in the chat box. Maybe if you can open it and then just see a couple of those questions and take them, Prof. And there are many, so if you can see a couple and then try to tackle all of them. And then the ones that you have already answered, of course, they've already been covered.
Thank you very much. Yeah, I've answered the radiation one. How does an artificial intelligent machine that is created by a human being become more intelligent than its creator? Kindly clarify. The reason is very, very simple. Maybe just to turn this question into its head. How is it possible that a car that is designed by a human being can travel faster than a human being? It's actually a very valid question. Just because we are the makers of things, it doesn't mean that whatever we make cannot do certain things better than us. We made a car actually travels faster than us. We make a machine called artificial intelligence, and the car does not evolve, which basically means whatever you create is what you get, what you have. And artificial intelligence, you can even make it so that it can learn independent of you, the maker. When it sees things, it stores them. When it sees difficult situation, it evolves so that it can go over those difficult situations. In fact, now people have made artificial intelligent machines that are able to make other artificial intelligent machines. Very, very good question. Now, artificial intelligence and jobs. Now, what is happening is that because an artificial intelligent machine cannot join a trade union, it means it cannot be able to disrupt the world of work. Because of that, the people who are profit-driven are eager to replace human beings with machines. Sishaba, you will know, we used to work for South African breweries. When we automated the Port Elizabeth brewery called Ibai, it could be operated by around about 50 people, producing more alcohol than its predecessor that had almost 4,000 people. You know, very, very key. So the world of work is going to shrink. And it will have all sorts of implications. It will have implications on whether we should introduce a universal basic income. It will have implications on whether we should now start making robots pay tax. It will have implications on who is going to buy the goods that robots make if people do not have jobs that support, that give them disposable income. Now, what do we do as Africans? Firstly, we need to make sure that we have a stake in this artificial intelligent world. We must have a stake in it. Our people must get educated. They must understand the technology. They must understand how to create this technology. They must use it to create new companies that are going to operate in the African continent. There's no reason why there is no Facebook version, African version of Facebook. The Chinese have the Chinese version of Facebook. There's no reason why we should not have the WhatsApp, the African version of WhatsApp. The Chinese have their own version, it's called WeChat. All these things, we are going to conquer them by getting informed, by making sure that our people are just as educated as people of the rest of the world, and by looking around to solve the problems that are around us. Now, SMMEs into the research. How do we get SMMEs into research and development cycle? It's about time we get SMMEs. It means SMMEs, you have to approach your universities. If you are a small and medium enterprise who is interested in creating new products, and you have not visited your local university, then you are dragging us behind. The SMMEs must be involved. They must come. You can come to my office, and then we can be able to see how we can work together going forward. Can we deploy? Yeah, absolutely. Humans do not own intelligence, okay? Somebody is answering. Why is, 5G towers have been destroyed in the developed world as being the cause of public health. Why is this technology not being embraced as expected? Look, I mean, I think there is politics in everything. The same way the Uber cars in Europe were being destroyed. I am sure that if Uber was a European company, the destruction would not have been as vigorous. 5G, the country that is leading in 5G is China. And there are many other countries that are not very happy about it. So there is that in the mix. And we should just not get caught up in political fights over who dominate a particular technology. What we should focus on is for us to also understand this technology and to also be part of the value chain of developing some aspects of these technologies so that at least we have a stake on them. Now, is South Africa ready to embrace 4IR? No, I think yes and no. We do have 4IR requires high competence of math and science. And we know the crisis that we face in our schooling system. We need to work hard to bring this crisis in math and science to the past. If you look at many of our universities, the pass rates are not where they are supposed to be. As long as the pass rates are not where they are supposed to be, then we can never be ready. If you look at the research and development, not all universities in South Africa are equally doing research and development. As long as we are not solving our own problems in our backyard, then we will not be ready for the fourth industrial revolution. But the Presidential Commission has come up with recommendations. The recommendation of developing the National AI Institute. The recommendation of investing in human capacity development. The recommendation of establishing the Advanced Manufacturing Institute. The recommendation of developing the National Data Center. The recommendation of incentivizing, especially SMMEs, to deploy technologies of the fourth industrial revolution to improve productivity. The recommendation of creating infrastructure of the 4IR so that our people are not excluded, but they are included. The recommendation of making sure that all our laws are adapted so that they are in line with the fourth industrial revolution. And the recommendation of making sure that the presidency developed a coordinating unit to make sure that all these things that we are doing in the fourth industrial revolution do not just end up in as a document, but they become a lived reality.
While we are reading those questions, Prof, I've also sent some that have come from people watching live on YouTube and Facebook. I'll send them on your WhatsApp, on your phone. If you can also take time to look at those, or I can read them to you.
Mm-hmm.
And once again, thank you very much, Prof, and everybody for staying on for these important chats. We are live on YouTube and Facebook, the EmpowaWorks digital platforms, and we are listening to Professor Tshilidzi Marwala talking about everything fourth industrial revolution, 5G, myths, and all that.
What is the future of housing delivery? I think we need to have new safety standards for housing. Normally, when you have a high-rise building, you probably will have to take your plan to the authority for it to be approved. And now, given the fact that social distancing is actually preferable, especially if we don't get a cure, we need to start now thinking about what are the new standards that we need to develop for us to protect our people. Densification. There was a densification project here in Johannesburg, especially here in Melville, where they are going to have a densely populated people. I always say to this to my people, sometimes we take strategies from countries that simply do not have land. If you go to Japan is probably, is it even bigger than the Free State? Probably not in terms of geographical size, but it has what? More than twice the population of South Africa. So the issue of social distancing cannot be afforded as easily as we can. If you come to South Africa, and I drive quite a lot to go to Limpopo, to Venda, if you drive from Johannesburg in the N1 to go to Venda, all you see are just forest. If you pass Pretoria, the next build-up place probably will be in Polokwane after almost 300 kilometers. So we actually have an advantage of ensuring that there is social distancing to prevent diseases such as COVID-19 and any other transmittable diseases that are going to come. So,
and then one of the questions around whether we have sufficient security infrastructure to handle 5G. Not sure what it means, but there's a question for you, Prof.
Look, I think probably is talking about cybersecurity. Now if you are going to have faster communication, does it in any way have an impact on cybersecurity? Well, if you have faster computers and you can be able to transmit information faster, then of course it means that you can be able to break a code or a password much faster. So we need to investigate how much of that we should be worried about. The 4R makes it possible for people to rely on the intelligence of machines and robots to work and socialize. Is it not a curious case that COVID-19 is disrupting how close-knit social interactions and necessitating virtual remote contact? Absolutely. One of the things that we have done here at the University of Johannesburg is that we have moved completely online. We are some of the first universities to move our people completely online. Of course, we had a bit of an advantage because even before COVID-19, our teaching was what we call blended learning, which means online plus contact. Now, when COVID came, We just moved the contact to online. Of course, there are other problems. We are having people in rural areas where connectivity is not very good because of that digital divide. And we have to find ways of reaching them so that they are not left behind. All those challenges are there. I'm glad to say that 98% of my students are actually regularly coming to the classroom, which is the digital platform that we use to teach our students. And of course, the COVID-19 has basically thrown us into the digital age. I have to also add that the digital platforms that we are using are not ideal, because digital education, online education at its best, will require virtual reality. Now, in some imagined future where bandwidth is no longer an issue, where the speed of the internet is no longer an issue, the teacher, you should be able to see a teacher in front of you as a hologram, because that technology is there. Just last year, the President Cyril Ramaphosa was addressing us in Midrand, but at the same time, his hologram was in Northwest. So it was as if he was also there. Those technologies require bandwidth. They're there. A hologram, when I was in high school, when I was attending the International Youth Science Fortnight, when I was in high school, when I visited England, the hologram was there. They were showing us holograms. What needs to be done is that we need to deal with issues of data so that these people can come and teach us virtually, as if they are in the classroom. So colleagues, thank you very much for inviting me. Now the 1 hour is almost done. Just in closing remarks, education is very, very important. Education is very, very important. When China was modernizing, and Deng Xiaoping, the man that we can single out as a person responsible for China as we know it, he came to power in 1978. Paramount leader of China, was never a president of China. Many people think Deng Xiaoping was a president of China. They came to him and say, Comrade Deng, why don't you become a president of China? He says, why? I'm old. There are younger people, more educated than me, who can do a better job. Why should I be president of China? And when he was opening up China to the rest of the world, some people in the Chinese Communist Party came to him and said, you are a revisionist. You are taking us away from the path of Marxism, Leninism. And he said, no, socialism is not about poverty. And he came up with a theory called socialism with Chinese characteristics in order to take China to the rest of the world. When he realized that technology is much more outside China than inside China, he took a map of China, drew a circle in a place called Shenzhen in China, and he said, this is a special economic zone where the laws of China are not going to apply, and we are going to use these special economic zones to attract companies, especially from the United States, to come and set shop here. And after a while, our people will know how to make those things that the Americans are making. And of course, as they say, the rest is history. And ultimately what he said was that Chinese leaders must be more educated and must be more technically adept. And because of that forward thinking, China has emerged as arguably the most powerful country in the world. We can also do that as Africans. If we pay attention and we invest in our people, and we invest in learning, and we invest in our schools, the schooling system, not just as teachers, but also as parents and as communities. Thank you very much. Kia libua, niabonga, dia libua. Thank you.
Thank you so much, Prof. And you leave us on a very high note. For everybody that wants to Join us for the next conversations on Monday with Professor Bonang Mohale. Please use that WhatsApp number 082-088-5262 or visit the EmpowaWorks website where you'll get more information. And for everybody that was watching this live on all our digital platforms, thank you so much. And for everybody that was able to join us directly via Zoom, I'm sure you found this enriching and thought-provoking. To you, heavily indebted. Thank you very much, Professor Tshilidzi Marwala. Until next time, bye-bye, everyone.